Welcome to part 6 of this Python course. This section covers collections in Python, specifically the dictionary and set data structures.
A dictionary falls under these new types of data called a collection, and there are two types of collections in Python. The first type is something known as the dictionary, and then the second type, which we'll briefly look at, is something called a set. A dictionary is one of the most important structures in Python. Basically, a dictionary consists of a pair of data inside braces. Inside braces. You all know what braces are. Open braces and closed braces look like that. Now, instead of using an index number like we do for a sequence, remember strings, lists, and tuples all use index numbers. A dictionary uses something called a key. And the key is incredible because it doesn't have to be a number. A key could be a whole word. This makes the information inside a dictionary very descriptive, and it becomes very easy to find as well. Every key in the dictionary then has a value associated with it. So in terms of the structure for a dictionary looks like this. Let me just get some spaces. Structure of a dictionary looks like this. We start off with an open brace, then have the first key, a colon, and the value associated with that key. That is then separated from the next key value pair using a comma. So we can then have the second key, colon, with the second value, another comma, and so on and so on. We can add as many of these key value pairs as we want. And finally, we will close off that structure by closing our brace. Now, inside, one important thing you need to know is that keys in the dictionary are immutable, whereas the values are mutable. This is very important, so let me just highlight it. What do we mean by that? Right. Any key that is created in a dictionary may not be changed. You can delete it, you can add a new one, but you cannot change an existing key inside a dictionary. The values, however, value there, that value there, may be changed. So they can be updated, they can be changed, you can do whatever you like with those values. All right, so let's jump into an example showing you how this dictionary structure works. So I'm going to create a dictionary. I'm simply going to call it data, and I'm going to add some values in it. So I'm going to start off with the first key, which I'm going to call name, and I'm going to give it a value. I'm going to call it Jack. So there's our first key value pair. I've given the dictionary the key, which is called name, and the value of that key will be Jack. I'm then going to add another key, and this key will be age, and I'll put a value in there of 42. And let's put another key in there. I'm going to say gender, colon, and I'm going to say male. Hopefully, because the name is Jack, so we start off with male. So that creates a dictionary. That dictionary has 3 items in it. The first item is name and Jack. The second item is age 42. And the third item is gender male. If we print that out, we can see what it looks like. It comes back and tells us that that is a dictionary item. We've got the keys, name, age, and gender, and the values are Jack, 42, and male. So let's have a look now at a few methods and how we can extract data from a specific dictionary. If I want to know what keys are available inside a dictionary, I simply need to print out the following. I can say print, my dictionary is called data, print data dot keys. And that will then come back and say, right, the dictionary keys are name, age, and gender. It's exactly what it is. There's name, age, and gender. So you can extract the keys quite easily. We can also do exactly the same for the values inside a dictionary. So if I say print data.values, it'll come back and only extract the values. It comes back and says, right, the values are Jack, 42, and male. Now what you'll notice is that when you extract the keys or the values, they come back as a list. You see that? They are surrounded by brackets. So name, age, and gender is a list, and Jack, 42, and male is another list there. The reason it's returned as a list, because now we can work with it using a for loop, for example, which is really easy to do. We can also extract values from that dictionary, individual values. And to do this, we use the key for that value. So if I want to print out the age value, if I say print data, now if this was a list, that value that we wanted would be in position 0, 1, 2, 3. But now that we have a dictionary, this value belongs to the key called age. So instead of having an index number, we are going to use the key to extract that value. So inside brackets, we put in the key that we want to use. So I'm going to extract the value for the age key in the dictionary called data. And if I run that, it comes back with a value of 42, which is correct. Age has a value of 42 associated with it. I can combine all of that into a string now. I can say print data, let's extract the person's name. Is so let's see what happens now. I'm asking it to extract the name from the dictionary, so the value associated with the key called name, and the value associated with the key called age, and it's going to add it into a particular string that I'm creating. So if I run that code, it'll come back and say, Jack is 42 years old. So it's extracted the name, then added is to it. It's then extracted the age and added years old to create that whole string. Now remember that I said dictionary keys are immutable, but their values are mutable. That means we can change it. So this allows us to be able to work with the dictionary. To start with, I'm going to add another key value pair to the dictionary. Let me do this. Adding another key value pair. To do that, we type the name of the dictionary, we open our brackets, and we enter a new key. We can do whatever we like as long as it's not an existing key in the dictionary. So if I say data height equals, and I add a height in there, I have now added a new key value pair to that dictionary. So if I print out the dictionary called data, we can see now that we've still got the original 3 key value pairs inside it, but we've added a new one now. The key is height and the value is 1.87. We can also delete a key value pair from a dictionary. We cannot change a value, but we can delete it and we can add a new one. So if I no longer think it's politically correct to add in a gender field, I can delete it by saying delete EL space data, and then we tell it which key to delete. In other words, for this one, I'm going to delete the gender item from that dictionary. So once I've done that, I can then check the dictionary again, and we can see that the dictionary now consists of name, age, and height only. That field there has been deleted completely using that code. Now the keys cannot be changed. So I cannot change age, for example. But what I can do is change the values associated with any of these keys. So let's assume that the person's birthday has come now and I want to update the age. I can say data age equals 43. Okay, it was 42. I'm changing it to 43. And now if I print out the dictionary again, we can see that that value has been updated from that position. So the name is still the same, the height is still the same, but that key value pair has now been updated. Now, the exciting thing about dictionaries is not only the fact that you can work with keys instead of index numbers, it's the fact that you can put anything you like into it. So let's just get a new heading here. The values inside can be scalar values like we've done, 42. They can be strings. They can be lists. And they can even be tuples. Let's do an example here. I'm going to do another example using marks for subjects like we did previously. So I'm going to create a dictionary consisting of marks for term 1 exams at school, for example. So I'm going to create a dictionary. I'm going to call this dictionary marks, and I'm going to now start entering some values. So the first value I'm going to enter in there is going to be for maths. And I'm going to enter a mark in there of 54. We can then add the next key in there. Let's put in physics and a colon so that we can enter the mark. Let's go 65. And finally, again, I'll add in English, colon, and I'll add in 76. So we've got maths, physics, and English as keys, and I put the marks in there for those 3 subjects. If I want to look at what the dictionary looks like, I can print it out, and there we have maths, physics, English, and we've got those 3 marks. Now, we can update those marks because those marks are values. They are not the keys. Keys are maths, physics, English. They cannot be changed. But the values of 54, 65, and 76 can be changed, which is quite nice. So what I'm going to do now is to update the dictionary, let me get the spelling right, with marks for the whole year. So term 1, 2, 3, and 4. So to do that, I'm going to say marks for maths equals And then I'm going to create a list containing those marks. It was 54. Let's add some more marks in there. 72, 43, term 3 was a bad term, and then 56. And I can do the same for the other subjects as well. I can say marks, physics equals, and we can create another list. So we've got 65 was the first mark. Let's make up some more marks. We got 53, 61, and a 58. And then finally for English, the English marks were 76. Let's go for 69, 51, and 62. Right, so if I run that code and I now display my dictionary, we can see that at each key value, we have got a list of values as associated with those keys. So those three lists are the 4 marks associated with each of those subjects, which are as the keys. So for example, if I want to display the 4 marks for maths, if I say print marks math, it comes back with those 4 marks. Now, I want to show you how we can actually access individual marks for a specific term. This is a list. Those 4 marks are contained inside a list. And you all know how to extract data from a list. We use the index number. So if I want to extract the mark for term 2, which is the second mark in that list, I have to use the index number for that list. So I would have to say print marks. I then specify the key we are looking at, which is math. Sorry, would be in inverted commas, and then I specify the index number inside the list. So that value there for term 2 would be index number 1. Remember, index 0, 1, 2, and 3. So that would be index number 1. So if I place a 1 in there and I run that code, it comes back with a mark of 72. So just like we had with lists where we had 2 index numbers, when working with dictionaries that have embedded structures inside them, we use the key for the position we want to extract and then the index number for the list that we want to extract. And this method works on any type of sequence. It can work on a string, on a list, or on a tuple. Okay, so further to that, what I want to look at now is how we can iterate through a dictionary. Remember, iterate means moving through values in a dictionary. So let's start off with a few examples. First, I want to show you how we can read the dictionary keys. Earlier, I said you can read the dictionary keys by saying data.keys, so we use the keys method. But now there are specific structures we can use. An iterative structure is a for loop. So I'm going to start off with the word for, and I'm going to say I'm going to create a variable called key in marks. So what's going to happen now in this loop is that the marks dictionary is going to be iterated through, and every time it goes through that dictionary, it extracts a key from that dictionary. So if we now print out the key, it'll come back and say, right, the keys are, first one was maths, the second one is physics, and the third one was English, which is exactly what it was. There is the dictionary. We've got maths, physics, and English are the 3 keys. There is another method we can use. Dot items allows reading the key value pairs in a dictionary. So if I, for example, say print marks dot items, it comes back and says, right, the dictionary items are maths and all the marks, physics, all the marks, and English with all the marks for English. Now, marks.items is not the same as just printing marks. This comes back with a structure, which is a dictionary item structure. And that structure is important because it, again, allows us to run through all the values inside a dictionary using an iterative loop, like a for loop. So if I now use this structure and I say for key, comma, value, let me spell it right, for key, comma, value in marks dot items. What it's doing now is it's extracting two values each time it goes through this marks dictionary. It extracts a key and puts it into the variable key. It then extracts the value field and puts that into the variable called value. And if we now print those two variables, key and value, it comes back with each key and its associated value. There's the key, the value, finally the key of English and the value associated with English. Now this is quite important because it allows us to extract data from a dictionary in a very nice way. So what I'm going to do now is to display the values from this dictionary in an easy to read English way. So I'm going to say for key, comma, value in marks dot items, I'm going to say print. I'm going to start off with the subject and I'm going to display the key. And then I'm going to say print term 1. The value is in the form of a list, so we can access these values using index numbers. So I'm going to say term 1 was value 0, and I'm going to add a % sign to it. And we can do the same for terms 2, 3, and 4. So if I say print term 2, value for term 2 will be value 1, index number 1, and we'll add a % to that. And then I get a little bit lazy, so I'm going to just copy, paste, and change the value. So term 3 will be value 2, and value 3 will be for term 4. Right, so there we have a structure. Now let's have a look exactly what will be displayed when I run that code. Comes back and says, right, subject, maths, term 1, 54%, term 2, 72, term 3, 43, term 4, 56. And then it moves on to the next subject. So by using this iteration, we can go through all values inside a dictionary and extract the keys and each value and display them in a really nice way. If we want, we can add a space in here. So let me put a \n. Remember, \n is for a new line. So if I run that again now, we end up with a little bit of separation so that we can see exactly how each subject is structured. If you look at the code I wrote here, first of all, this was the first example, and it is not very efficient code. Because if you look at it carefully, you'll realize that term 1, 2, 3, and 4 have got incrementing values, so the term changes by 1 each time, it goes from 1 to 2 to 3 to 4, and the index number does exactly the same. It starts off at 0, then 1, then 2, and then 3. Every line are pretty much the same. So I can create a structure. Instead of printing out those 4 lines of code, I can create a loop structure to run through each of those 4 lines. So let's try that. For key, comma, value in marks.items. And I'm going to start off just like we had. I'm going to say print subject, and the subject was the key. And then I'm going to create another loop structure. I'm going to say for I in range, what will the range be? I want to go through values from 0 to 3, 0, 1, 2, and 3. So I'm going to say for I in range 4, because remember, the value you state there is not included in the list. So that will run through all values of I from 0 up to 3. And now I can say print term we can't have term 0, so term will be I plus 1. Add a colon in there. And then I'm going to extract the value, and the value will be I. And then we'll add the percent sign. Right, so if I run that code, it comes back with what we had previously. The subject is printed out using that line. That is the key. And then the marks are printed out using this loop structure. So I starts off at 0. So it prints out 54. Then I becomes 1, prints out 72. I becomes 2, prints out 43. And lastly, I becomes 3, prints out 56, and that little loop structure ends, and it goes back to the outside loop structure and gets the next key value pair. If you did want to add a space in here, we can actually do that as well, simply by putting a little check in there. I'm going to say if I equals 3, use the print statement. Okay, so what it's doing is that if I does reach 3, it's going to print a blank line, which will just put a line in between there. So if I run that now, we end up with exactly the structure that we had previously. Then the last collection I want to introduce to you is something known as a set. Now, a set is an unordered collection of values. These values are unique, and I'll explain to you what I mean. As an item that is unique, it means that if you have multiple items inside a set that are the same, every item subsequent to the first one will be deleted or discarded. To create a dictionary, it's created exactly like a, to create a set, it's created exactly like a dictionary without the keys. All right, so let's create a set, for example. Let's go set1 equals, and we open and close our braces. And then we can put values in there. So I'm going to add some values, and I'm going to say 1, 1, 1, 2, 2, 5, 4, 3, 4, 5. I'm just choosing arbitrary values here. So I've created a set, and this set just contains arbitrary values. Now, if I print out that set, it comes back and it says, right, set 1 is equal to 1, 2, 3, 4, 5, 6, 7, 8. You'll notice that all the duplicate items in the set have been deleted. So the 3 1s are no longer there. There's just a single one. We've got a 2, another 2, and a 2 there, but there's just 1 2. So every duplicate item is simply discarded. All right, and that is very, very useful. I create another set and I give it some values, 2, 7, 9, 5, 8. Right, let's just print it out, print set 2. We can see that we've got 2 sets now. Set 1 is 1, 2, 3, 4, 5, 6, 7, 8, and set 2 is 2, 5, 7, 8, 9. What I'm going to look at now are some mathematical functions that can be used on sets. So the first one is a union. We all know what a union is. I'm going to create a variable and I'm going to call it UN, and that will be set.union. So the dot union is a method belonging to all the sets in Python. So if I say set.union and then open my parentheses and add the 2 sets in there, set 1 and 2, I can then print it out. If I say print union equals, comma, UN, it comes back and says, right, the union is 1, 2, 3, 4, 5, 6, 7, 8, 9. So what it's done is it's combined the 2 sets. That's exactly what a union is. So you'll notice that set 1 had values of 1, 2, 3, 4, 5, 6, 7, 8. Set 2 had some combinations. There was a 2 in there, a 5, a 7, an 8, but it had an extra value of 9, which has now been added into the overall union. So a union consists of all values, unique values in both those sets. The next function to look at, or the next method, is the intersection. And the intersection is equal to set.intersection. And again, we pass it 2 values, set 1 and set 2, and we can then print out that intersection. Intersection equals enter. So if I run that, it comes back with some values, an 8, a 2, a 5, and a 7. So the intersection tells us the values that belong to both sets, which is 8, 2, 5, and 7. The 9 doesn't belong to set 1, and the 1, 3, 4, and 6 doesn't belong to set 2. So the intersection only shows us the values that belong to both sets. You'll notice that the values that are displayed are not ordered. All right, just like I explained up here, a set is an unordered collection of values. Okay, so the values inside a set are not ordered by default. The last method I want to talk about, difference. And here I'm going to put a rider. Now, to create the difference, and lots of students get this wrong, we can say set dot difference, but this only gives us the difference in one of the 2 sets, not both of them. All right, you have to be very specific. The method we want to use for creating the overall difference between those 2 sets is something called symmetric difference. We can then open our brackets and give it the 2 sets as arguments. If I now print out equals, what did I call it? Diff. That's not going to work. Run that, it comes back and tells me that the difference between those two sets is 1, 3, 4, 6, and 9, which is exactly as we expect, completely opposite to the intersection. So the intersection are the values that are the same in both sets, and the symmetric difference are the values that are different in both of those sets.
Thank you for watching. Please subscribe for more content.